Okay, my friends, so we'll do a quick example of a matched pair t-test, and you'll see the mechanism for it pretty quickly. Like I said in the intro, it's just a t-test. All we've got to do is do one quick adjustment to get the data into the form we need it to be into, and then it's just like the last playlist. Okay, so how many of you have ever watched television, whether it's cable or whether it's streaming or whether it's dish, or I don't even know how TV is watched anymore, and wondered when the commercials, the ads come on, my God, they're so freaking loud compared to the show itself. Well, apparently, that's not supposed to happen anymore because of something called the CALM Act, the Commercial Advertisement Loudness Mitigation Act, passed by Congress back in 2012. So what's going on? Like if there's this act that's, in place to mitigate loudness, why are people still complaining about the loudness of commercials? So I thought to myself, I don't watch enough TV to worry about it really, but I said to myself, this is a pretty awesome way to do a match pair t-test. So what I did was I installed a little dB counter on my phone, and I decided, this was a couple years ago, to look at randomly selected shows and the commercials immediately following them. Okay, and I don't remember which shows these were and which commercials these were. This was about 5 years ago I collected this data, but it doesn't really matter. So what you can look at as you look left to right is you can see the show and then the commercial immediately following it. So in other words, each commercial is paired with the show. So you'll notice in this first one, the peak decibel reading from the show was 73 decibels. The commercial peak decibel was 75. Now, just as a quick aside, a decibel is a measure of sound pressure. Basically, the larger the number, the louder, the more intense sound. So any number that's bigger in the peak decibel cell under the show means the commercial was louder than the show. Okay, the next one, 73 to 74, also louder. The next one, 72 to 75, also louder. The next one, 72 to 72, the same. The next one, 69 to 67, that's actually less. The commercial was quieter. So the question then is, if you scan left to right on this data, you might notice that there are a couple where the commercials are quieter, if you will, than the show. But they seem to be many where the commercial is louder than the show. So I think this is a perfect place for a hypothesis test. Now, matched pair versus just a normal little t-test. This might look like two different data sets. It might look like the peak decibels from the show is one data set, and then the commercial is a second data set. But actually, the data set is not here yet. What we want to look at is the commercial paired with the show on average louder. So what we need to do right now is we need to create, I'm going to do a quick little bit of coding here. I'm going to do equals commercial peak decibels minus show peak decibels. I'm going to hit enter on that. Now, this is going to be pretty boring to look at actually, because we could do these very quickly in our heads, right? Those are the differences. Let me center these and bold them so they stand out. And actually, let's color the cells. Maybe, actually, if you want, we can get fancy. We can conditionally format them. Let's highlight them. If they are less than 0, let's make them red. And if they're greater than 0, let's make them green. Okay, so now we've got some zeros that are white, and then we've got a few red cells and a few green cells. So it looks to me that the greens outweigh the reds and the whites, but we can't do that just by saying there's more greens than reds and whites. This isn't a proportion. We need to look at the values of those numbers, and that's why a t-test, testing an average, is the perfect choice for this. This is now our data set. This right here, these are the differences in decibels. Those are the differences in decibels. That's our data set. So what we're going to do is, real quick, I'm going to do the average, the sample standard deviation, and the sample size for these three things. And I'm going to need real quick here, make room for it. There we go. Equals average, the average difference is likely positive. It is 0.391, 0.4, not a whole lot. Standard deviation is going to be 1.7. That's a pretty wide standard deviation for an average. It's pretty close to 0. And how many data points are there? Let's take a look. All right, 23 data points. Okay, now hopefully you're realizing this is a t-test. This is exactly what you were plugging into the Excel calculator last week. But before we plug that into the Excel calculator, let's get a template sheet up. And let's start constructing the first few cells of the template sheet to make sure that we know what we're actually plugging into the calculator. All right, so here's our sheet. We're definitely going to be looking at an average. So I'm going to make that red so we know it. And what average are we going to be looking at? Well, we're going to be looking at the average difference. Whoops. In the commercials and the shows. And I'm going to put the average difference in max decibels in the commercials in the shows. Let's not make that a capital. Average difference, max decibels, between, not in between. I'm just being grammatically picky now. Between the commercials and the shows. Let's go with that. Okay, now, let's look back at our data again. We took a look, oh, that's the Excel calculator. We'll get back to that in a second. Here's our data. Now, we notice that our average is positive. The average is positive because on average, the commercials were louder by 0.4 decibels than the shows. I did the individual differences of each. So I think that if we're trying to show that the commercials are louder than the shows they follow, I think we want to test that mu, the average difference, is going to be greater than 0. I believe greater than 0. So, I mean, and again, that means statistically significantly greater than 0. Is the data we're seeing evidence of that? The opposite is going to be less than or equals to, so let's drop that symbol in if I can do it. Less than or equal to, there we go. This is looking pretty good. Looking pretty good so far. So we have it. We have an average difference that we're going to be testing against. Always T for an average. So we're going to make that red here. There we go. Now, I think we're ready to go. We have a null hypothesis we're testing against, the value 0. And you can test against any difference. I very rarely test against any differences other than 0. It just seems to be the most sensible one if you're trying to find a difference between a matched pair. I think it's time now to get the test statistic and the p-value out of the Excel calculator, which means I got to grab these 3 data values, copy, stick them into our Excel calculator, paste, special. There they are. We're testing against a null of 0. Make sure you do that. Make sure you turn your number lock on too so you can. And okay, so I got everything set up that I need to get set up, and I have to do a right-tailed test because we're trying to see if it's greater than 0. Okay, so I've got myself set up. Let's take a look at our that's a big looking p-value. Let's open up the result. Oh yes. So the test statistic ended up just over 1 standard deviation away, which was not far enough to be statistically significant. P-value carries 14.42. So my test statistic is going to be about 1.1. Let's go ahead and fill that in here. Your test statistic is about 1.1. Lowercase, please. Okay, P-value is about 14. I'll do a squiggly equals because I'm feeling saucy. Squiggly equals 14%. All right. So that means that although our sample average of 0.4 decibels, that was our sample average difference of 0.4 decibels, was greater than 0, this tells us it's not significantly greater than 0, which means we can't reject the null hypothesis. It does not appear that the commercials are louder at maximum than the shows they follow. And I spelled almost all those words wrong. At maximum dB. Than the shows they follow. So, yeah, they're louder, but not statistically significantly louder. What type of error? Type 2. Absolutely type 2. Which means we could have failed to notice the statistically significantly louder commercials. Commercials. There you go. There you go. Not dupes. Goodness gracious. You can tell it's Monday morning. Okay, so there you go. There you go. You have tested and found no statistically significant increase in max DBs between the commercials and the shows.